Hi everyone, hope you are all doing good. Welcome to another video in the series of differentiating your skills. What essentially I am saying is this is my own definition of full stack development. Right at some point in time, people thought that full stack development is just about front end, like UI UX skills. If you know some JS library, Angular JS, React JS, like that, then you can say that I am a full stack developer. But no, right? Just by knowing front end doesn't make you a full stack developer. The other definition that I heard is okay, if you know some front end and some of the database like RDBMS, NoSQL, any database system knowledge, then you can say that it is full stack. No, that is also not full stack. And the other definition, which many people thought proper, is knowing some front end skills, knowing database skills, and also knowing the back end programming language skills, Java, .NET, or anything where you can build some APIs and all, API development, services development. So if I know front end, back end, and then database, then people thought that is actually full stack development. And many people, almost 80% of the people, think that that is a full stack development, but that is not even a full stack development in my opinion. What I am saying is, when I say full stack, the name itself says it is complete stack, which is expected by the organization these days. We should know many more than just front and back end and then database skills. So that is what I'm trying to, that will help you to differentiate your skills essentially. And this is the expectation from all companies these days. What are all the things? That is what I listed here. And then I have already recorded some videos earlier on this topic. So if you did not go through the videos, I recommend you to go through those videos so that you can understand more. So in the previous video, I have completed use of IDEs, right? What are IDEs and different ways of writing programs in Python, including Jupyter, Colab notebooks also I have covered. I have also covered some additional skills, and use of virtual environment is something that I have already completed. And as part of advanced topics, I have completed command line arguments in Python. All those videos are available. Each video is independent on its own. That means you can still learn something just by going through one video. You will get that particular skill. And as I promised, I will try to cover all these topics in different videos. I don't know whether it will go to 50 videos or 60 videos, but we'll try to see. So today I am planning to cover the third one, which is unit testing, code coverage, mock tests, and all this particular portion. Okay. I will also try to provide links to the videos in the description. So just make sure to go through the description to watch the earlier videos. Okay, let us get started. Unit testing. Okay, so this is very interesting topic. Testing as such, right? Before we even try to understand unit testing, let us try to understand what is testing. Testing is paramount for any software product or application, or even for hardware product or hardware application, where it ensures that it is meeting the expectations of stakeholders. So, testing will ensure the quality of your product or service, which means it will try to verify, it will help you to verify to make sure that it is meeting all the expectations of the stakeholders. Again, when I say expectations, everyone will have their own definition. My definition of quality is entirely different. I have written a LinkedIn article, quality is everything. A small article, you can just uh, search for my name, Anand Bemulapati, and then you will be able to find the article I wrote, I think, 10 years back. Quality is everything. It is one of my favorite topic as well. So when I say it is meeting the expectations, many people will stop at functional requirements. But these days, with cloud adoption and all, with more expectations from even from end users, not only from organizations, you also need to ensure that your product or service or application or even project is meeting all the functional and non-functional requirements as well. It is not just about functional requirements. That means it is working as per the expectations is not enough. from a functionality point of view, also from a non-functional point of view, cost optimization, operational excellence, reliability, security, scalability, multiple things, right? All these things also you need to verify to make sure that your software product or application is meeting all the functional and non-functional requirements. That is how important it is from a testing point of view. What is testing, right? That is, it's very imperative uh, for any application that you are going to deliver into the market, be it B2B or B2C, whatever it is. Okay. And all testing, how do you ensure, right? There again, it's a very broad topic and there are so many topics available. Probably you might have heard about sanity testing, smoke testing, regression testing, A/B testing, multivariant testing, and load testing, performance testing, stress testing, and security testing has become very, very important these days. And that itself will take probably an entire video. I will try to see if I can record one more video only on security testing. But again, testing is very important, and unfortunately, in some companies, they are trying to push the product out of the door just to meet the timelines, not ensuring the quality of their product or application, which is very unfortunate and not good. I don't recommend that approach. So, but there are ways in which you can still speed up, right? It is not you are wasting time by ensuring the quality. You can speed up with automation, and a lot of frameworks are also available. So all testing from a different, irrespective of the category or the type of testing that you are doing, you can classify them as white box testing and black box testing. Two high level types or categories, you can say, white box testing and black box testing. Just remember, black box is, it is black, I don't know what is happening. Just as an example, if you are given a remote to switch on the TV or for testing, you can just press the remote and see if if I press the power button, TV is able to switch on or switch off. If I try to change the volume, if I try to change the channels and all, whether it is working fine or not. So when you are doing that kind of testing for your remote, essentially what you are doing is a black box testing, because I don't know what is happening behind the scenes. When I press a button, all I am checking is if I am changing the channel, if I am planning to go back to the previous channel or go ahead for the next channel, whether it is working fine or volume increase, volume decrease, these are all working fine or not, without knowing the back end details. I don't know what is happening behind the scenes, right? You are just testing without knowing what is happening. It's a black box for you. So that kind of testing is called as black box testing. All your performance testing, trust testing, load testing, all this scalability, they will all come under black box testing. White box testing is just the opposite, where you know exactly and you have access to the actual code and you know exactly what is happening behind the scenes, and then you will be able to not only have the knowledge of what is happening, but be able to change the code, update the code also as required to make sure that it is meeting all the quality requirements. So unit testing is a white box testing category, mostly performed by developers or software engineers, where they have access to the code and then they will be able to verify. They will be able to write multiple test cases to ensure the quality of their particular code or application, and then be able to modify the code as required. So unit testing is a white box testing method where smallest portions of the application are tested in silos. So we can have functions, methods, every function, every method, every line of code. In fact, you need to ensure that that is tested properly and it is working as per the expectation. And we do that in isolation to verify it is your code is working as expected. Okay, what are the benefits? Again, there are too many benefits. I don't want to list everything, but it will help you to improve the quality of your code, and then it will also help to identify bugs or issues early in the cycle so that you have an opportunity to fix them before you go into the deploy your application to the higher level environments or even into production. And since you will have better quality of your product, you will have more confident in terms of deployment. So more confident deployments, easy and automated regression testing. That means if I try to build my application or product. As it evolves, you will write more and more code. For every release, you will write more code. And then you want to ensure that you are not breaking, the new code is not breaking the functionality. Again, functional or non-functional requirements, both. When I say functionality, that is what I mean. It's not, the old one is not broken. Right? That is called as regression. Regression means if your code is breaking, a new code is breaking something, then it's a regression issue. So you can automate all those things with unit testing, and better code coverage also. So many organizations these days, they are also insisting on code coverage. So we'll see how to do all these things with a hands-on demo also, not just the theory. Just wait for a few minutes. We'll be there. Okay. Similarly, then popular frameworks. So when it comes to unit testing, multiple frameworks are available. You don't need to take entire burden on your own. Lot of frameworks are available, and it all depends on the language that you are using. Whether you are using Java language, .NET language, or you are writing PHP or JavaScript or Go or Rust, whatever is the programming language, you have multiple types of unit testing frameworks. So when it comes to Java, JUnit, TestNG, TestNG is most advanced. So these unit testing frameworks are available. Similarly, for NUnit, you have frameworks. For Python, you have different types of frameworks. JavaScript, every language has their own framework. Okay, so in this particular video, we'll try to understand unit testing in the context of Python. Again, the focus should be on independent isolated logic validation at a unit level, method or function level. And if you don't have access, if that particular the actual code is accessing some external system like APIs or databases and all, if you don't have access, you can, there is a concept of mocking. You can actually create stubs, or you can mock the external data or external objects. That is called mock testing, that you can use as part of your unit testing. We'll discuss all these things in a while. And this is widely used in some of the latest practices like TDD, BDD, shift left, and all test driven development, which encourages you to write tests before you even write the actual implementation code. Right? That is test driven development, where you write the tests. And behavior driven development is mostly related to requirements, to ensure that your requirements are fulfilled as per the business requirement and business expectations. Similarly, shift left practices will encourage you to include testing as part of every phase within the SDLC, whether it is requirement phase or design phase or development phase, deployment phase, everywhere you want to ensure that testing is part and parcel of what you do. So it shows the importance of testing, right? By making sure that testing is part of everything. That is called shift left practice. Anyway, I don't want to go into the details, but let me know in comments if you want me to do a separate video on any of these topics. For now, let us just move ahead now. So now let us start our unit testing hands-on demos with the Python context, Python language. So you have unit test and doc test. These two frameworks are part of the Python standard library, which means you don't have to install any software. But there is another popular library when it comes to unit testing in Python, that is called PyTest. It gives a lot of advanced features as well. Documentation is available. You can just Google unit testing, unit test documentation, or PyTest documentation. You can just pause this video and then try to replicate the URL, or just Google, and then you will be able to get the URL yourself. Okay. And we are going to cover unit test framework, where I don't need to install any external libraries. So we'll just cover unit test, but don't worry, we'll cover all the concepts that are required from a unit testing point of view. Everything has their own advantages and disadvantages. Though PyTest is more advanced, unit test is also very, very important and very popular when it comes to Python unit testing. So from a unit test framework point of view, what is the building block? The building block is to ensure that your class is derived from a class called test case. Test case is a class that is available as part of your unit test module. So unit test framework follows object oriented programming concepts. That means you need to define a class whatever class that you are writing to conduct a unit testing. Let us say unit test class, and that class must be derived from test case. So without object oriented programming, you cannot you cannot implement unit testing in Python. What are the high level steps? Let us just see high level steps and then we will write the actual program. So first you will write test methods. So in order to write the test methods, as I mentioned, first of all you need to write a class that is derived from test case, and then each method you can write 2 methods, 10 methods, 20 methods based on your requirement, where each method should start with the name test something, test products, test customer email, test password, test whatever. So the name should start with the word text. This uses object oriented approach, which means you need to write classes. So you write the class and then you define a lot of test methods. And then within each test method, you use something called assert methods. So there are a set of assert methods that are available as part of the uh, test case class within unit test. And these assert methods are again uh, very common across all unit testing frameworks. Even if I go to TestNG or JUnit or NUnit, any other unit testing framework, it will have every framework has a set of assert methods. That is what you are going to use within your code. And then once you use asset methods, you need to run the test cases. To run the test cases, you just have to use a runner that is available. So in case of unit test within Python, test case is having a runner. You can run either from the command line or from the IDE as well, integrated development environment. I will cover both. I will show you both in the video. And then once you run the test cases, it will show you the result, how many test cases are failing or passed. And if something is failing, again you need to go back to the code and then make changes as required. Again you run the test cases. So this process will continue unless you fix all errors or bugs, or you get enough code coverage also. We'll see what is code coverage and how to verify code coverage also. And you may use some advanced features also, like text fixtures, decorators and all, which we will try to understand in a while. So you repeat the process until you are satisfied. Okay, so these are the high level steps. And assert methods, when it comes to assert methods, you have test case class, which is having assert methods to assert some values to make sure that whether the value is equal to something, not equal to something, or the type of value, or even existence of a variable, assert in, assert not in, like that. So different types of assert methods are available. Let me just click this URL. I will just try to open unit test. So here, if you see the documentation, this is how you will import that unit test module, and then you write some test class which is derived from unit test. Okay, so this is how inheritance works. By the way, if you don't understand object oriented programming concepts like inheritance, abstraction, polymorphism, all these things, so let me know in comments. I will try to do a separate video on object oriented programming concepts. But essentially the building block is class. Fundamental of any object oriented programming is a class, where you define a class, and this is called class inheritance. You are deriving your class from test case class. And then if you see the test methods, they are starting with the word test. This is how you write, and within that you will just use assert methods, assert equal, assert true, assert false, right? Like that, different assert methods. And this is called unit test dot main. This is the runner class that is available to run your tests. Okay, so like that, multiple assert equal, assert true, multiple assert methods are available. You can just try to go through the documentation, and you can also run from the command line. Okay, so let me go back to the PPT. Okay, now we'll write a demo. So let me just open command line, and I will try to go to temp folder. Let me remove everything. I think this is already empty, which is good. So you don't have anything in the temp folder. and I will try to run tests here. Either you can run again, in the previous video I have covered multiple ways of writing programs. Uh, since we already covered IDEs, I will try to show how to write the programs within VS Code, and I will also try to show you from the command line as well. We will cover both. So how do we open VS Code from in the current folder? Once you install Visual Source Code, you just have to do code, type code, and then dot. Dot means current directory. Open VS Code in the current directory. That is what you are essentially saying. And then press enter. So Visual VS Code will be opened in this directory, in the temp folder. See, if you see temp, it is temp. It is opened here. Let me close this welcome screen. I just want to write a new file. Let us say this is test addition dot py. I am just writing a new class, a new file here, test addition dot py. What we are trying to do here is, let us assume that there is a method which will add two numbers, and I want to verify that the functionality of that method by writing some unit test cases to ensure that it is working properly. So let us define a method. First of all, define add numbers. Okay, so this is already writing the code for me. That is the advantage of IDE. So return a plus b, that's it. Okay, so now I am going to define a class test addition. Okay, so already it is writing a lot of code for me. I just pressed tab, that's it, right? So code is already written. Add positive numbers, add negative numbers, add mixed numbers. So three test cases it is already writing, but you need to ensure that your test class is derived from test case. So that means I want to import here. I will just import unit test here, and then here I am going to derive my class from unit test class. Correct. So already IDE is writing the code for me, which is good. So this class is derived from test case, and then add positive numbers. So I am calling add numbers. Here these are called different test cases. See, positive is one scenario, adding negative numbers is another scenario, adding one positive, one negative is another scenario, adding zeros can be another scenario, adding zero. Let us say I just want to add zero. I can write another method, define test add zero. Okay, that's it. Add zeros. And assert, I am calling assert equal. You can just do okay, instead of this, what I can do, I will remove this. I think self dot assert equal. I will just use assert method directly. Instead of doing this kind of assert, I will just use assert method directly. Self dot. Okay, add mixed numbers and then add zeros. Here, correct. Self dot assert equal. That's it. So now how many test cases we have written? 1, 2, 3, 4. One is to add positive, one is to add negative, another is to add mixed numbers. See, four test cases just for one method, just to test the functionality of one method. Like that, you can come up with positive test cases, negative test cases, remote scenarios, everything you should cover as part of your testing. Now, to run all these things, I need a runner. So I will just define unit test, a main method, and then I will call the unit test.main, which is the runner. That's it. Save the program, and you can just run it. Let me just resize on the top. If you can see, so this this button is there. You just need to click on that button and then run it as Python file. Run Python file. See, ran 4 tests. In case if you get an error or if it is prompting you to select an interpreter, you need to select your Python interpreter, whatever is installed. In my case, I think Python interpreter, it is able to identify. So directly it is able to run. What is the result? If you see, ran 4 tests and then OK. It is showing that it is able to run 4 tests. So because there are 4 test methods that are available and result is OK. That's it. But if I make some error, let us say 00 is 1, let us say I want to fail my test method intentionally. So if I run now, it will show that there is an assertion error. So ran 4 tests and then failed. It is showing that one test case has failed. So that means, and where also it is showing your exact code. So in case if it is a problem in the actual implementation, you need to modify and update your code properly. In this case, I know that the problem is not with the actual implementation. The problem is with the test case method itself, because adding two zeros should be 0. It cannot be 1. So I will just update, and then once I run again, you will get the result. Okay, so this is the fundamental first program, let us say. Okay, so all we have done is importing unit test module and then deriving your class, whatever class name you can give, that is fine, with from test case, and then writing some assert methods based on your requirements, test methods, and then using assert equal here, assert equal. Okay, assert equal, why it is not, I think that code is wrong. Add numbers, you need to call that method, right? Add numbers, and I'm passing some numbers here also. I need to pass the numbers. Okay, 2 3 and then 5, that is fine. You can pass whatever, 2 plus 3 is 5, so you just need to make sure that even if I'm doing 12 plus 3, here you need to write 15. So IDE is helping me in this case, so you don't have to worry. That is the advantage of IDEs, and we have already covered IDEs in the previous video. So just go ahead and watch that video if you are interested. I will also try to provide a link in the video description. And then if you run same output, 4 tests ran and then OK. But what are these 4 tests? You are not able to see in the output. So if you also want to see the actual test methods in the output, instead of just a message saying that how many tests are run and what is the result, if you also want to see the actual test methods, you need to ensure that you are writing more to the output. How do we ensure that? There are 2 methods available. I will show you both the methods. First method is that main method will accept something called verbosity. You can just pass verbosity value 0, 1 or 2. 3 values it will take. And if I pass 2, what I am essentially saying is give me more details. Right? I want to see more details in the output. That's what we are saying. If I just change this, pass the value verbosity value 2 and then run the method now, you can see the change in the result now. It is not just showing 4 tests, it is also showing exact methods: add mixed numbers, add negative numbers, add positive numbers. That's it. Okay, so this will help you to get the more output, get more output in the console, where you will be able to see what are the actual methods and then what is the result at a method level and what is the overall result. We can do the same thing in the command line also. If I go to command line, and we already have a test edition, I will just do Python, run the program. That's it. Here also you will get the result. So this is one option to get more values in the console output. But let me just remove this for now. If I remove this, you will not get all the values, right? If you just run the program again, you are getting only the final result. So what is the other method? The other method is you can pass -v parameter, which is verbose again from the command line. If I run the program like this, again you will get more details. You will also see the actual methods and then result at every method. Okay. So this is another second level, right? How do we run the test from IDE? How do we run the test from command line? And how do we run the test to see more details as part of the output? That is the verbosity. Either you can pass verbosity parameter here like this, or you can just use that -v in the command line. Both will do. Anything will work. Okay. So this is the second enhancement to the same program. Okay, so let me just go back to the PPT and then we'll come back again to understand the more features. Okay, so all asset methods accept a message argument if specified is used as an error message on failure. If something is failing and if you want to provide your own message, you can pass an optional parameter to every asset method. Asset equal, asset in, asset not in, different asset methods are there, which we saw. You can, every asset method will have an optional parameter that you can pass, and you will be able to get that message. Let me just show this to you. I will go back to code again. Let us say that I have another method. Define, let us say, I don't want to test large numbers. That is fine. I just want to do test sample. Let us say I will just do test sample, and then self dot set true. I just want to do true. Check whether the value is true, and then instead of passing true, I will just say 34 is greater than 5. 34 is greater than 5, some value, right, which is true. So if I run the program, you can see that 5 tests uh, are run, and then within 5 milliseconds, output is okay. But here is, if I just say 55, this method will fail because 34 greater than 55 is wrong. Run method. So 34 greater than 55 is failing. So 5 tests ran and then 1 test failed. But if you want to pass your own message, what you can do is, instead of saying just assertion error, this is a system method. If I want to pass my own message, I can just do here my own error message for the sample test. Some message, whatever message that you are giving. Now if I run the code again, if you see the assertion error, false is not true, and then here this you will get the same message whatever you have given. So that is what we are essentially saying. For assert methods, there is a optional message that you can pass that will be displayed in case of any errors. Okay, so let me go back to PPT. What are the other features? So there are something called life cycle methods, which are also called as text fixtures, which are called by the framework automatically. So they are invoked by the framework automatically. So there is something called setup, tear down, setup class at the class level and then method level. So setup, for example, it will be invoked every time before a test case or test method is run. Setup is before running the test method, setup is run. After running the test method, tear down method will be called automatically. Similarly, at a class level, before running all the tests, if you want to do something, then setup class, there is a method called setup class available that will be run at a class level once before it runs any test methods. After all methods are run, if you want to do some cleanup or something, you can use this tear down class. This is another method. So these are some text pictures available. Let me just show you. So go back to the code. I will just define a setup method. Define setup, and then I will write some message just to show you that it is calling again and again. It is being called again and again. So setting up the test environment. So if you want to do any data preparation or any previous configurations that are required to run all your tests, this is where you will do, and this is done at a method level. So how many methods we have? 5 methods we have. That means 5 times it will be called. Let me just run the program now. Let us just try to observe the output. See, 5 tests ran and then there is a failure, that is fine. But if you see the output, setting up the test environment, test sample, setting up the test environment, setting up the test environment. See, 5 times it is calling for every method. So that is the setup. Similarly, tear down will be done. If you want to do any cleanup and then prepare for the next test method, then you can just use tear down method at a class level. Setup class and then tear down class are also available. Let me just change this to 15 or something, so that all test cases are passing. So if I run, no, all 5 test cases are passing, and then OK, and then setting up test environment. Whatever the message that I have given here, we can see automatically this method is being called before running every test method. So 5 times you can see this. So that is where you can use the text fixtures. These are called lifecycle methods. I am not calling them explicitly. They will be called. And again, don't worry and don't think that I am covering only unit tests here. If you just get this knowledge, this is enough for you to understand any other unit testing framework, whether it is Java testing, JUnit, TestNG, or some other PyTest or any other unit testing framework. The concepts are the same. So you just use different classes. That's it, based on the programming language. And what is the other concept? No, the next concept is you have something called decorators. So there are many decorators available here to get some additional features. Like if you can want to skip the test, some of the tests, you can just do skip and then at the rate unit test skip and then skip if based on a condition, skip unless, like that. There are a lot of decorators available. So let me just show you this one as well. I will go back to the code. Let us say I don't want to run this. I want to skip because this is just a dummy test case. So not setup, sorry. Sample. I don't want to run this sample. This is a dummy test case. Unit test dot skip. Skipping this test for demonstration purposes. I just write. Similarly, when you will use, see when you are doing TDD, test driven development, uh, in some cases, if the backend API is not ready or the actual implementation is not ready, you may just skip like this. And then once the actual implementation is ready, then you can run the test cases. But you will finish writing the unit test code at least. Okay, that is what you can do by using skip. Now, if I run the same program, see we had like 5 methods, right? If I run now, it is still running 5 tests, but here if you see skipped is equal to 1. And then what method we are skipping? If you just see this test sample, skipping the test for demonstration purposes. Whatever the uh, message that we have given, the same message you will get. So this is skipped. You can see this, right? This is skipped. So like that, if you want to skip in general, you can just use skip, or if you want to skip based on a condition, skip if and then skip unless a condition is met. Like that, lot of decorators are available. You can just go through the documentation. Okay, let us just move ahead. You can discover all tests automatically in a given directory. Okay, so let me just write one more test class so that we can use this one also. So if I have multiple test classes in my directory, so generally all code will go into SRC folder. So if you remember the project structure, the best practice is under the SRC folder you will have all the actual code, implementation code available, and under SRC there is a test folder will be created. Under test you will have all the test methods, unit test methods will be maintained. So if you want to run all the test classes at once, you can just ask the framework to discover and run. So I just want to create another second test class so that you will be able to see this in action. Let me go back to code now. So what we will do, let us assume that I have a class or I have some methods, set of methods to process the marks of a student. Okay, so I will just create marks methods dot py, and then let us define some methods. I want to get sum of all marks, sum of marks. Okay, and then okay, it is writing the code for me, which is good. Define average marks, and then define highest marks. Good, and then define minimum or lowest marks. Okay, good. So ID is writing all the code for me, but let me just verify whether it has written properly or not. Okay, total 0, marks in marks, total plus written total, that is good. Average is total by length, okay, good. And highest marks, highest is marks of 0, okay, it is just taking marks and marks, okay, that is fine. Or you can use built-in methods also. Python is having built-in methods, sum and an average, all those things. So I don't want to go into the details of this code, but let us assume that I have all the marks methods available and I want to test all these methods. This is my actual implementation of the uh, requirement, right, which is processing marks. So it is this method will give me total marks, this method will give me average marks, highest marks, lowest marks. You can write even more methods. Let me just write a test class now. Let us say test marks.py. I'm writing another test class. So what we need to do, you know how to write unit tests now. Import unit tests, that is the primary step. And then you write your test class test marks, which is from derived from your unit test case, that is correct. And then define marks, okay. No, I don't want to do any, I don't want to write this method. I want to write every one method for each. So let me just import the this particular class also method, sorry, file as well, so that I can access all these methods. So marks methods, import marks methods as okay, that is fine. Now what I can do is I can just define uh, test total marks, assert equal dot total marks. I'm passing some value 80, 90, okay, that is fine, which is good. And then define test average marks, good. So ID is writing all the code for me, nice. Test highest marks, good. And then test lowest marks, good. So for every method that is available here, sum of marks, average marks and all, I am writing one test method. If you want, you can write even 10 test methods to test all the positive cases, negative cases, remote cases, everything. Now my test class is ready. I will just run the test class. Okay. Verbosity also is defined. Now let me just run this. 1, 2, 3, 4 test cases are available. Test methods are available. Let me just run this. So indentation error. Okay. Test average marks self. There is some problem. Okay. Indentation. Why indentation problem here? Okay. Let me run it again. See, 4 tests and then failed, all are failed. Okay, error is equal to 4. Why marks method has no attribute called total marks. Dot total marks. What is that method? Sum of marks. Okay, I don't know why it is taken sum of marks. Dot sum of marks. Dot average marks, highest marks. So ID has taken blindly, and then I have also accepted blindly. That is the problem. That is what you need to be careful when you are using IDs. I forgot these method names. Highest marks, lowest marks. Okay, highest marks, lowest marks. Let me highest mark only. Okay, that is fine. Good. Let me run it now. I have updated the code. So you can see ran 4 tests in 7 milliseconds, and then verbosity is also given. That is why you are able to get all the methods. Test average marks, highest marks, everything is fine. Okay. So now I can run the same thing from the command line. If I just do dir and then python test marks, you will get the same output even from the command line also. You can give my verbosity, but it is not required because it's already given as part of the main method. You will get the same output. Okay, so now what I want to show you is there are two test classes. If you see test addition, one test class that is having 5 methods. Let me see, is it Python test addition. So you have 5 methods here and then 4 methods here. Total 9 are there in this particular directory. So if I want to run everything together, you can just use discover framework. Let me just go back to PPT and then show you. So discover all tests automatically. All you need to do is Python -m unit test discover. Okay. So that is the command Python -m unit test discover and then press enter. Setting up the test environments. So I think that setup method is there. That is fine. So but if you see the output, 9 tests. So it is able to discover 9 tests and then show you not just 4 or 5, because every test class it is able to identify automatically. It is able to discover automatically and then it is running all 9 tests. If you want to see the output more details, -v. Okay, so now test average, mark test, everything. It is showing exactly what are all the methods or test methods that are being called. So this is how, and even if you have 10 classes, 30 classes, it doesn't matter. It will discover everything for you. So this is another beautiful feature that is available, which will help you to automatically discover and then run all your test cases. Okay. But this output is not friendly, user friendly. Okay. If I am manually, I am running, then it is good. But how to automate this? Let us just see what are the other features. Advanced concepts. So you can create subtests, you can group multiple tests as a test suite, and then you can write your own assert methods. Let us say that the password cannot be more than 15 characters. Assert password length. That method is not available out of the box. You can write your own assert methods, and then you can use DevOps concepts to automate these test runs as part of your CI/CD pipeline, generating and hosting. We'll just see about the reports in a while. Okay, these are all the advanced concepts, and then you can just go through the documentation to see how to write subtests or how to group multiple test methods, a category of test methods, all customer methods into customer test suite, all products into product test suite, all sales into sales test suite, all orders into order test suites. Like that, you can create different test suites based on the category of tests, right? And then you will be able to run them properly. So all the advanced concepts you can learn. Another thing is mocking. So this is what I was talking about. There is another class called unit test.mock that is available in the same unit test module. It provides two base classes that allow you to mock. So mock and then magic mock. Two base classes are available. So in case your code is accessing any external libraries or external APIs or external databases, third party APIs and all, so you can mock these objects. So that is another advanced concept that you can learn, mocking. Okay. And this is available in every unit testing framework. Again, I don't need to repeat every time. Okay. So that is all about unit tests. Anything else that we missed? I think we are going to code coverage. Okay. Let me just go back to code. Anything else that I missed? I think skip we have covered. Test fixtures like setup, tear down, those things we have covered, and then I've also covered discover. Okay, let me just go through the PPT. Code coverage. Okay, so now if I want to ensure that my code is of high quality, one of the best practices, your unit test method should cover each and every line of the code, including if else conditions you might have written. So every block must be executed. So your code coverage should be 100% ideally, but at least in some companies they may just say 90% code coverage is good enough. So it is a good practice to write test cases that will verify the entire code. Code coverage will help to find if there is any code, that means any lines of code that are missing which are not covered by the unit test. And there is a coverage library that can be used to Python to get this particular code coverage report. Okay. And the best part is you don't have to write any code for this, and then I will just show you in a while. In Java also we have used I think Jacoco, Jacoco. Jacoco is one of the code coverage framework. I think, yeah, if I remember exactly. So that is the code coverage that is available in Java, but every programming language will have its own code coverage framework. So in Python, coverage is the library that is available. So what are the high level steps? So we just use the coverage module that is available within Python. So for writing unit test, we have used the unit test module. For writing, for checking the code coverage, we will use coverage module. Let me just go back to code quickly and then I will show you one thing. Let us say that uh, see, I am not writing this method. For example, assume that this method is commented out or I did not even write. That means what we are doing is you are testing only total marks, average marks and highest marks, but this particular method is not tested, because if this particular method is removed just like this, I am not testing lowest marks. That means you are missing this particular code from you are skipping this particular code from your unit testing. That means your code coverage is low, which is not a good practice. So that is why you need to ensure that all methods are tested properly, entire code is tested properly. Okay, we'll just see this in a while. Let me go back to PowerPoint. Okay, how do we run coverage against the testing code? You can just use python -m coverage run file. So let me just do this. Let me go to the command prompt. All I need to do is python -m coverage module is coverage module, and then run whatever class that you want to do. Let us say I want to do test edition. Run it. So it is saying no module named coverage. So this is not a part of the Python standard library. So you need to install it. So to install it, let me just create a virtual environment. Again, if you don't know what is virtual environment, how to create virtual environment in Python, you can just go through the video that I have created. I will also try to provide in the video description. Okay, so let me go back to command prompt. I will just create -m and then VNV. I am saying Python use module VNV and then create a unit test environment. Any name you can give. So this will create a virtual environment with the unit test directory. It will, so you will see a directory called unit test and then it will create a virtual environment. So if I type dir, you can see that there is a module called unit test available, and I want to activate this /unit test. Under scripts you will have activate. So now we are in the unit testing environment. So this is a virtual environment. Why I am doing this, you will understand better if you see Python virtual environment module. Okay, that particular video. So now I will install, because if I run coverage just like this, it is saying that no module named. So I need to install. So I will just say pip install coverage, because that is not part of the standard library. You need to install it. So now I think it is installed. Let me run it again. So now I am able to see the output. And if you see, what it will do is, once I run this particular command, it will create a directory called .coverage file that will maintain all the coverage details. So if you get an error, pip install coverage, that is what I mentioned here. You need to, if the module is not already available, you need to install that module. So now it will create a dot coverage. If I press dir, you will see that there is a dot coverage created, directory created. Okay. So get the report. You can also get the report by using python -m coverage report. If I just type report, if you want to see the coverage report, so this file is created, dot coverage file, but it is not directly readable for the humans. If you want to get the report in a friendly manner, you can just use this command python m minus coverage report. Now it is showing that there is a test addition.py file which is uh, a test class, and then 17 statements. One is missing 94% code coverage. I think one line is missing from here. I can just do this from IDE also. If I just go back to my code, I can open a terminal. Okay, terminal is already open here. I can just type minus m coverage report. Oh, okay. I'm not part of the virtual environment. That's why I'm not able to see here. Python minus m coverage. Okay. But let me discover everything. Okay. I will just, because it is running only one test class, I have two test classes, if you remember. I will go back to the PPT. You can also verify the code coverage for all the files. If you want to verify for all the files, you can just use python m minus m coverage, this particular command, right? Python m minus m coverage run minus m unit test discover. So this is going to discover everything. Let me run this. Python module coverage run minus m module unit test, and then unit test discover the current directory. So now it is running 9 tests, because five test methods in one class and 4 test methods in another class. Now you can get the report also, coverage report. If I just do report, it will just show you that there is marks methods.py. 3 classes are available, 3 Python files, and one Python file test marks is having 100% coverage. The other are having only 94%, 95% coverage. So total is 96% coverage. See, to get the coverage, we did not write any code. All we are just using is the coverage module. So it is as simple as that. But this is still not friendly. You are just getting in a table format, which is not friendly. And I will not know exactly why 94% only, where the 6% code is missing. So if you want to get those details also properly, we'll just go to the other feature. What is that? So if you see this, generate report python m minus coverage, you will get a table showing the coverage. This we have done. But the other better one is you can get the HTML output. Python m minus coverage HTML. If you just do this, this will create HTML COV folder with HTML files. So let me just do this. I will just show you. So instead of getting a table format, if I want to get HTML, all you need to do is Python m coverage HTML. That's it. Press enter. And then this is going to create HTML COV index.html. You can just open this file. Let me just open this. C temp the HTML COV, and then there is an index file. If you see this, just open this. So the entire code is HTML code is generated by coverage itself. We can see that marks method is having 95%, test marks is having 100%, and then what are the functions that are involved are included as part of this, and what is the coverage at a method level also you can see. Okay, 80% only. Lowest mark is having only 80% because I think that is not covered. So what you can do is you can just go back to the code. Let me open the code again. Where is code here? Okay. So I will just see why it is only 80%. If I just click on this lowest marks, it will just show you if lowest marks is 0, if marks is less than lowest, okay, lowest is equal to mark, okay. And why it is not one missing? I think it is just showing missing. What is missing? Lowest marks is missing, okay. uh, okay, the first value itself is the lowest one. That is what is missing. Okay, we'll just add the test method. Okay, but you can see this is very detailed one. You can just see what are all the classes and what is the coverage. You can just look at a function level. You can let it look at a class level, and then you can click, and then it will show you the exact code also. Assert true. Okay, this is skipping because we are skipping this one. Okay, so let me go back to the code and try to improve the percentage. So if I look at the percentage here at a high level, this is having only 94% test addition because we are skipping something. Let me remove that skipping. I don't want to skip that. So if I just go to which class is that test addition.py. If I just go to test addition.py and I remove that skip. I don't want to skip that. Okay, come back to the command line. I will run everything, discover again, and then I will get the HTML report. Now, if I just refresh that particular file, I will refresh now. Go to index, see, can you see that? It is 100% now. This was 94% earlier. Now we have improved the coverage to 100% because nothing is skipped now, right? Like this, you have just have to look at the report. So we used to automate this as part of the CI/CD pipeline, and then host all these reports on a daily basis to some directory. And then when you host it on a server, every day we used to get the reports. And then just by looking at these kinds of reports, you will understand what is the percentage and percentage coverage at a method level, class level, and overall also. And then see, and if there are any errors also, it will just show you, right? So all these things will help you to understand, to write unit tests, and then to look at the coverage also. What else? I think code documentation, that is the next topic. So we are not going to cover code documentation now. So that's all, right? So to recap quickly, so we learned what is unit test, how to write unit test classes, and how to use some of the features like set up tear down text fixtures, and how to use skipping tests and all like decorators, and how to look at the code coverage in a simple table format and then in HTML format, and how to use different kinds of features that are available. So mock testing and then advanced concepts like building a pipeline with CI/CD, all those things we did not cover. Probably we'll try to cover as we learn about the other items in the next videos. Okay, and I hope this was helpful to you. So just try to share with your friends in case if you think this helped you. That way you will be helping your network as well. And then try to follow because I will be adding more videos to coverage all the 15 items so that you will become a full-fledged full stack developer, not just a full stack developer that understands some UI and then some backend and then some database. Okay, so I think this is already very long. We'll just stop here, and then I will see you guys in the next video. Until then, take care. Happy learning.